We recently had the opportunity to air tightness test a 280-year-old home in the Netherlands, testing with 3 different air tightness testing technologies. Today I'm really excited. We're in the Netherlands where we're going to be testing different air tightness testing technologies on the same house to see what results we're going to get. We're here with Anthony from ACIN ATT. He's going to run through and talk about what his company does. Let's get into it.
Thank you for inviting me here. I'm Anthony from the ACIN ATT. If you translate it, it's leakage hunters. And yeah, we are with 3 of us. And we are measuring residential buildings, the air tightness, and also the larger buildings.
Yes.
And we see that we are growing, so
cool.
That's really nice.
Yeah.
And today we are in Wageningen to measure this residential building. Yeah.
Beautiful. So what's the level of air tightness that you're experiencing in Amsterdam with all the homes that you're testing?
It's really different.
Yeah.
Sometimes it's good, like 1 ACH, or lower, or above. So about 1.5.
1.5 ACH.
Yeah.
Perfect. And so the range is very consistent, and are all the homes achieving that level of air tightness?
No, not all of them, no. Like, let's say 40%.
Okay.
Yeah.
So are you guys going in and testing these homes before the plaster goes in, or just after plaster and that's it?
Both. So sometimes we do 2 tests.
Yep.
So when they're a hallway, and they're almost done.
Before they put the plaster,
Yeah.
you can see the air barrier, right?
Exactly.
Right, okay.
They're using a lot of concrete.
Yeah, of course, rigid.
So that's very easy to.
Of course it is.
Get a good air tightness.
Yes.
We have our own report that says, okay, you can improve here, etc. And they start improving, and then we do the last test. Yeah. And then we say it's around 1. Yeah. So not 1.5 or 0.5, but 1.5.
Right, okay, 1.5 ACH?
Yeah, exactly.
ACH.
Yeah.
Okay, gotcha. Yeah.
Because I needed to translate it in my head, because we are using the Q15.
Yes, which is another leakage way of expressing leakage, but that's per floor area, isn't it?
Exactly.
Yeah, and at a different pressure level as well.
Yeah.
Which will confuse everyone.
It's very confusing, yeah.
Yeah. So Anthony, what's one of the key things that you do as a part of your air tightness testing on homes in Netherlands?
What we do is we're using the blower door machine to create under pressure in the building, and then we start hunting the leakages. Oh. And we're using the camera, the infrared camera, during the winter, and smoke during summer, to find leakages.
In apartments or close quarters living like this as well, there's a lot of interconnection in between apartments where cooking smells and stuff can also come across. That's another critical thing that air tightness testing can also tackle, isn't it?
That's really true. Yeah, that's true.
Yeah.
There are many complaints about smell of the neighbors, that they're cooking too much and that they smell it. Yep. And then we're focusing on the internal leakages.
Wow. Yeah. And I guess considering that we're in Netherlands, that'll be also dope. Marijuana smell that could easily come between apartments too.
Yeah, everyone is smoking, so nobody's complaining.
Yeah, of course.
I'm kidding.
Why would you complain, right? All right, so we're on an ACH of 3.
Of 3, yes.
Not too bad. It's an older home. 300-year-old home, this one.
Yeah, it's recently renovated.
All right, cool. Well, let's have a look around with some smoke. If we can close this. Yeah, look at that. It's firing out. Let's close that and we'll look for some others. But you can see it just keeps pushing out. How does that look?
Yeah, it's
pretty good. These have all been sealed shut though, haven't they?
Yeah, they're shut.
Yeah.
That's why they are now good. But
is that going to leak?
No, I don't think so.
No.
I wouldn't expect it.
No. Whoa. Jeez.
That is because we wanted one window to be able to open.
Yeah, of course.
I have to do something about this.
Yeah. Look at this for a potential avenue for air leakage.
You can see smoke over here. So it's pulling back the air, so There's also leakage over here. Maybe there's a gap here.
It's definitely leaking in there, isn't it?
Yeah.
Bust through.
Yeah, the window it's okay, except for the corners.
Yeah.
Whoa, that's my door.
Where's that coming from? Oh, underneath around the window frame.
It's here. We found another small one.
Yeah, that's
Same.
leaking. Oh, here's another massive one. This one would be big.
More of the same.
Yeah.
You see it in the...
Yeah, they've been silicon.
Yeah, it's going outside to the PV panels.
This is the heart. This is another important thing of air tightness, is finding open sewer stacks. So we've managed to find an open sewer pipe that's for the condensate,
Yeah,
isn't it?
exactly.
But that needs an S-bend of some sort.
Yes.
And it hasn't got one by the looks of it.
Maybe you can put someone here. Yeah.
Well, you put it there. But yeah, all right. So that's something that
Yeah, it's also connected
Nick
here.
needs to do. So Nick, how long have you guys been around for?
ACIN is around still 1965. This year we had 1964, so we had our 50th birthday.
Yeah.
And I'm with ACIN still since 2001.
Now you guys have got some pretty amazing hardware that's very pertinent and important for air tightness testing. The flow hood is an amazing piece of machinery that you guys have engineered.
Yeah.
And now you've also got the
ATT.
Yes.
Air tightness tester.
Very different to your conventional air tightness blower door testing equipment.
Well, yeah, maybe, but it's exactly the same principle that we use for the measurement.
Yep.
The only thing is that we don't need a blower door.
Nope.
We only need a fan that makes a pressure in the house, under or over pressure, and we have a pressure sensor, which looks a bit odd.
Yep.
We have it here.
Yep.
This is the pressure sensor, so to speak. This you put in the house, and it will measure the pressure inside and outside, and the difference is your air pressure that you are causing with your blower door or with a fan. And you can use the ventilation system of the house to do that measurement.
Yeah, of course. Now, I guess as we start getting more airtight buildings, this becomes more of a potential for doing, especially high volume testing in apartments, like to set up a blower door where you're also deleting or not seeing the leakage rate from the door as well that you're setting up the blower door to. This is definitely a potential operation that can be done on a lot cheaper, I think.
Yeah, well, we see it as we also consider it as an add-on to the blower door.
Yeah, of course.
It was, the development of the instrument was subsidized by the government in order to stimulate air tightness testing in the Netherlands.
Cool.
And we test from an apartment, they test, if you build 50 apartments, they have to test 2 apartments with the blower door.
Yes.
And then they assume that the other 48 are fine.
Yes.
And they are saying, well, it would be much better if you would test all the apartments.
Of course.
So do the first 2 with the blower door together with the ATT, where you baseline the ATT as it were, you calibrate it. And then go into those other 48, turn on the ventilation system, just look if you get a number which is decent.
Yeah, which is in the ballpark.
Within the ballpark. You can do an exact measurement with it, but normally that is still done with the blower door.
Correct.
And of course, the other thing is with the blower door, if you find with the ATT the house is not good, you have to move in with the blower door anyhow to find the leakages. So it's a hammer and a screwdriver. It's different tools to achieve the same thing, good air tightness.
Absolutely. And in an apartment complex also, all the exhaust systems are going to be pretty much the same.
Yeah,
so
exactly.
You've got a good understanding of how much air is going to be moving. The only real variance is going to be just duct runs and stuff that are going to outside, but that's
I was in a project together with Anthony, who was just on the video.
Yes.
In Groningen, in the north of the Netherlands.
Wow.
And we had so many different numbers.
Yeah.
And he could walk around and he would say, oh no, that duct is leaking.
Yes.
And you had an air tightness, an ACH of 4.
Yes.
And another apartment, there was a guy who was very eager to improve his own apartment, and he was way below 1.
Yeah, wow.
So that was a big variation, which we could spot very quickly with the air tightness test.
Yeah. So now this, though, it basically stores pressure inside it.
Well, how do you work with a blower door?
Yeah.
You turn the blower door off and you measure your baseline pressure, inside-outside difference about 0.
Yep.
Well, in this little enclosure in the top is a little valve.
Yep.
And the valve is open to the air when you have all the ventilation turned off.
Yep.
And once you start the measurement, use it with an app, and once you start the measurement, the valve closes. And then you start turning on and off, and there is a differential pressure sensor sitting on top.
Yep.
You turn on and off the ventilation or whatever you use to make pressure, and it will registrate the pressure drop.
Wow.
Or pressurize, the differential pressure.
Yep. It's amazing.
So this is the powered flow hood.
Yes.
And that's what makes it special.
Yep.
It compensates for its own resistance.
Yep.
And then takes a measurement.
There are not many that do that. So this basically has a little DC motor in here that equalizes the pressure going into it so it can work out more accurately.
Yeah, you have here static pitot tubes.
And this is what you're going to be using on the...
Well, for the ATT, you need to measure the volume flow.
Yes.
So we measure it with either the flow finder or with our new instrument, which is way lower in price, the VentiFlow, which is a passive flow hood.
Gotcha. So for the ATT, because we're bouncing around a little bit here with different technologies, but with the ATT, you need to have a good flow hood as well as the ATT, which stores the pressure inside it.
If you want to do that very precise measurement, yes.
Yes.
But if you are doing the job I was referring to, you know the ventilation system from all those apartments, and they do a ballpark 60 liters per second. I'll name a number, probably it's a bit more. No, 60 is reasonable.
Right.
Then just use that 60. Don't start measuring all those because you want to know whether...
It's just in the ballpark, right? Yeah, it's in the ballpark.
If you do the ballpark thing, then you have to know the volume flow from the ventilation system.
Gotcha.
If you want to do a more precise measurement, we did that. We did that in the apartment. It was a very quick job. You measure the...
Yeah, because all exhaust systems will have a certain amount of resistance with their duct runs to the outside, right? So it'll be, they won't move exactly the same amount of air.
No.
But still, you do it on the first apartment and use that as a general reference. Because really what you're looking for when you're testing a whole lot of buildings in one day, which you can with this, is if there's any large variance of failure of an apartment. Really, I mean, that's what everything comes down to.
We saw, we had an example in a new building, houses in somewhere in the north of the Netherlands, and they had an error in the roof. There was really something open in the roof, and you immediately find it.
Yeah, of course.
Even with the ATT, you could just go around the house and you would suddenly hear the
pressure just wasn't getting there.
And so then you pick out that kind of things.
Yep. We're also going to be testing a pulse system as well here to see if we can just line everything up with the same level of air tightness.
Yeah.
Can you run through the principles of this one too?
Yeah, I can do that. And we can show it later.
Yep.
With this unit, you have both. Like with the blower door, you have the pressure generator and you have the volume flow measurement. But this is the same. Here is a compressor. Here is a vessel, you call it a vessel?
Vessel, or something that stores the pressure, right?
Yeah, it stores the pressure. You bring in a lot of air, up to 10 bars, and then you have an enormous amount of air, and it will release the air in a big pulse, and then it will slowly move away the air. It will slowly leave the building.
Okay,
and it still will be giving air.
Yep.
And the flow coming out, when there is a sort of a stationary situation, the flow coming out is the same as the flow going out. And from that signal, they calculate the air tightness.
Okay.
And so that's a very quick measurement, seconds.
Yep.
But you first have to load, you have to pressurize the vessel, and that takes about sometimes 5 minutes.
If there is a failure, I mean, at the end of the day, you've got to bring in the blower door. So this is another tool to be used to, I guess, cookie cut test enclosures.
So it's not a tool to find the leaks.
No.
And to go back to the ATT a little bit, if you have a relatively airtight house, you have a vent system that can make a reasonable flow, then you could still use that flow to do some leakage testing.
Of course.
But still your best tool is, of course, the blower door, because you want to, for real leakage testing, you need to go to 50 pascals.
Yes, you do.
Then you get then you open up all the leaks that are there.
So it's more accurate with the blower door. You can't troubleshoot with this. You may misfire, and this can also have issues with building envelope that moves with pressure.
That's what they are saying, but on the other hand, it's a very successful tool and recognized in the standard tool in the UK already. And we did some testing in Groningen, and I did some testing in other buildings, and it really performs. There was a big farmhouse in the north of the Netherlands, what they call a stolp farm, and that's a farm with a roof like this, and then you have to imagine the roof is like 12 meters high in the middle. Wow. And around it, it's walls by 10 by 10 meters. And I did a test with the pulse tester. And Anthony's colleague did a test with the blower door. And we were in a tenth of ACH. For that particular farm. So
So it was about a 2 ACH. Oh, that's pretty airtight.
Yeah, for such a building, that was crazy.
Yeah, that's crazy.
And he actually found out where the leakage was.
Yeah, wow. Using
the blower door.
Oh, using the blower door, of course.
Yeah.
So now we're currently just trying to get an accurate air tightness test with the blower door to line it up with the ATT and the pulse. Is that correct, Anthony?
Yes.
And also for my official report.
Yes, of course.
QV10, the Dutch QV10 report.
So this is the ATT?
Yeah, see the light is blue. So it means, and the light is burning blue continuously. And here you see this is sort of gray. It means it is connected. The Wi-Fi is connected. And now you can set all your settings here, your air tightness unit, your flow rates, your flow exponent, because it's a 1-point measurement. You need to make an estimate for your flow exponent. So it's charged.
So we've got a charge now on the pulse.
And then from there you can either look at old measurements, load measurements, or you can start a measurement. So now everything is quiet, the ventilation is off, and now I say start measurement. Look at the light. I start the measurement, and you hear a click. It's very so green means the valve is closed. And now it's actually measuring the pressure. Here is 0 pressure difference.
Wow.
Now look what happens if I put it down. What would you expect if I put it a meter down?
Has it already started going down there?
Well, that's temperature. I put my hand on it. There are some fluctuations, but the clear signal is. So I increase the pressure now. Here, there you go.
The pressure goes up.
Yeah, of course.
Wow. When you put it down.
Yeah, of course. There's more air on it.
Of course.
There's 10 Pascal. I put it down a bit bluntly, so it went to 20, but then it goes back to about 8 Pascals, which means this is about 80 centimeters.
So right now, walking up the stairs should change it again.
Yeah.
Can we do that?
Yeah, sure.
This is crazy.
Yeah, I lifted it up, see?
Yeah.
And now we go up the stairs.
Wow, so it's less pressure as we go.
Yeah, of course. Minus 40 Pascal.
So when you take this measurement, you need to take it from downstairs where you...
Doesn't matter.
Oh, it doesn't matter.
Put it somewhere. And leave it there.
And leave it there. It can't move.
This is just to demonstrate the differential pressure sensor.
That's amazing.
And now we go back downstairs again. And all the little movements, see, it's very sensitive to
temperature.
To temperature.
Of course.
So, and that's why the suitcase is a bit polyethylene. It's insulating.
Yes, of course.
So you would like to. You bring it in the house. You start preparing. He should acclimatize a little bit. And then you can take your measurement. But even if it has a trend, the software calculates those pressure differences quite exactly from the algorithm. Here, so now he started the blower door.
It's gone straight into it, hasn't it?
That's the supply.
Where are we? We're above.
We come from 10 and we are at 70.
It's just so responsive, isn't it?
Yeah, well, that's what pressure is. It goes with the speed of sound. So if he gives me the number of the airflow now, we could calculate the air tightness. Immediately, you're ready to go.
And you're just referencing the pressure from the pressure that you had in your home before the blower door turned on. So you've got a little piece of atmosphere from outside, in essence.
In essence, you have, but well, normally you would expect if you don't have any ventilation, and the same pressure. That's what you do with the blower door, similarly. So it will go down now in a bit. to the next step.
Yeah, it goes it's slowing down.
It's gradually slowing down.
Oh, gradually. Yeah, you can see it.
No.
Wow,
you can see
the blower in action.
Yeah. Hup. Look. Chuck.
Wow, that's cool. That's cool.
Yeah, the light is green.
Yep.
We have our base pressure.
Yep.
And there it is already. Wow. It went up to 70.
86 Pascal.
Yeah, 86. Here, look, wow. 86.
87.
Yeah, and this is the trend the unit has.
Yep.
So when he stops it,
yes,
the signal will come there.
Yeah.
In the meantime, while we are measuring,
yes,
the atmosphere is changing.
Yes.
And those are hectopascals.
Yeah, right.
So the vessel is closed and it changes a hectopascal. How in the hell can it measure?
Yeah, right.
Well, that's because it has a low pass filter.
Yeah.
It has a little capillary.
Yeah.
And that drains the air when there are big air changes, air pressure changes.
Sure.
So that it can measure those small Pascal differences. So, and that's why you always will see that the vessel is filling up or draining its air.
Yeah. Okay, Anthony, tell me, what results have we got?
Yeah, we are done with the official measurement.
Yeah.
And we have a ACH of 3.
Okay.
3.01.
Okay.
So yeah.
Okay.
And overall, I think the measurement was good. The correlation is 99.96.
You don't get much better than that.
6.8.
Huh.
Perfect.
Very standard.
Very, very
happy.
Yeah.
So what's my QV10 specific?
It's 0.72.
Okay.
So there's still some improvement to be made here.
Absolutely.
Yeah.
Yeah.
Okay.
Yeah, let's try to get to 1.5. I think that's still possible.
Well, we are firing up, we are loading up, we are charging, pressurizing the vessel.
Yeah.
It goes up to 5 bars, has a lot of air in it, and we will release the air in a big puff. And when that is done, it will tell us the same things that the blower door is telling us. It should tell us the same things. No, this is now ready to go. That was a pretty strong one.
Yeah, it was. It's truth.
Yeah, it's a valid test.
Okay.
Yeah.
Yeah.
But it doesn't immediately calculate at 50 Pascal, so I have to recalculate it.
Okay.
2.78.
Oh, 2.78.
2.8. You can already see from the pressure signal, it was now 9 Pascal.
Yep.
85. I expect the others to be around the same number in total, so we have about 170 cubic meter per hour. First the baseline, so we have to leave the door open.
Yep.
And we have to turn on the unit.
Blue blinking.
Which means it doesn't have connection. That's not so strange because the app has not started yet.
Yep.
Yep, we are connected. Mm-hmm. And we have the door open, so we have inside and outside pressure is the same.
Sure.
Whatever ventilation is going on.
Yep.
We'll start the measurement.
Sure.
And there, you hear the click, green, the valve is closed.
Yep.
Yeah.
It's just collected its pressure, right?
Yeah, it is
That's
collecting its
green.
pressure. It's green. And now hopefully we get some. There you go. Immediately. Strong signal.
Yep.
Close the door.
Yep.
See, if you close the door a bit too hard, you get this overshoot.
Yes, of course.
And now it's going to do a little bit of trending.
Yep.
But we have to wait. The algorithm is telling me the red dot. It means, hey, that is where you're pressurized.
Yes.
And the blue dot is saying this is about the delta P I have. So I'm now ready for the next measurement.
Yep.
So come here.
Yep.
And see when I open the door. Yang.
Yeah. Wow. Yep.
There you go.
Yeah. Cool.
And in fact, I just said what I was expecting, given the air change that we found with the blower door.
Yes.
And this is what I expected, about 4, 5, 10, so somewhere around 10 Pascals.
10 Pascal. Beautiful.
In fact,
That's
I
what
can
you
move on to the next house.
Sure. Sure. Yeah. 10
But
PA.
let's finish the measurement.
Yeah. Wow.
So we close the door again. I close it a bit hard again.
Yep. It's overshot.
Overshot. Of course, it's neater if you want to do a 0.2 decimal measurement. Okay. And then we have a ACH of 2.7 plus or minus 0.4.
Wow. Okay.
Same ballpark.
Yes. So 2.7.
Yeah.
We got 2.9
9 and 3
on the pulse, and then we got 3 with the blower door.
Yeah.
Yeah, very similar. Yeah. Cool.
Yeah, and it really has to do with the flow rate.
Of course.
What I forgot, I added the bathroom and the toilet, but there is a huge exhaust rate in the center, in the technical room itself.
Yeah.
Those 3 add up to 250, 300.
Yeah. Blower door testing got the most accurate result. Enables us to also do a bit of troubleshooting, which we had to do, right?
Yeah.
Yeah. There's still a bit of work to do on your home, though, from an air tightness perspective.
Yep.
Yeah, what are you going to be aiming for?
Oh, if I can get it down to 2.5.
Yeah.
And if I can do the real big things, like obviously there is a problem in the construction. The window is leaking.
Yeah.
And those big things. But on the other end, with the 3.0, I already have an extremely comfortable house.
Yeah. Yeah.
Which is, we don't feel any drafts. Yeah. Don't forget that 3 ACH is measured at a 50 Pascal, which you hardly get in your house. Then,
yes, true.
Then you can't leave your house anymore almost. So I'm happy. I of course, I would have liked to see a lower number.
Yeah.
And but it also teaches you that ACH isn't the holy grail.
No,
it certainly is an indication.
No, but still, compared to homes in Australia, I mean, that is still a pretty miraculously airtight home, especially considering this is double story.
Yeah. I know that one of the most famous guy in building constructions is Joe Stribeck.
Yes.
And he says 3 ACH is a good way to go.
It is.
You don't need to live in a prison.
Absolutely. Now, we used 3 different technologies here. The blower door, which is the original. This is what we all use for our air tightness testing. The pulse gave a very similar result to the air tightness test that was done. And then we went on to your ATT. Now, this is a fantastic product that you've developed here. And its real strength is being able to test apartments and all of them, pretty much, right? Because at the moment we're testing predominantly a sample amount of apartments. And this will easily be able to work out or weed out any abnormalities in apartments. When they build so many of them, you've got to expect that they're going to have some sort of anomalies.
So you do the sample with your blower door. You use the ATT on the same side to check it. And you run into the other apartments, turn on and off the ventilation system, or if you have a calm day like you saw in the video, you don't need to turn it on and off. Just open a window and close it, or a door. And you immediately know, hey, listen, this is similar to the other apartments, or it is not. Perfect. Thank you very much for showing us these thanks for coming all the way.
It's a pleasure.